Guys, we are back. Jon Su from Internetrics is with me, and he's going to be telling us about securing Silverstripe applications so that they are safe and sound when they're out in the wild where the unicorns live. Jon, stage is yours.
Okay, thanks, Julian. So hi there. Well, just to start things off, my presentation doesn't actually have unicorns in it, so just so you know. So just to give a little bit of brief background about me, my name's Jon, so short for Jonathan. So I work as a software developer alongside Mikey, who was the one that just gave that previous talk at Internetrics, as you can tell by this background. So for those who didn't listen in on that previous talk, Internetrics is an Australian Silverstripe partner, and we've been a partner for over 10 years. And we're based in Wollongong, which is about an hour south of Sydney. And we do all kinds of things here, mostly digital, web dev, data analytics, amongst other things. And then for those who'd like to become my best friends on social, there's my email address, as well as my other social handles. I'm pretty active on the Silverstripe Slack channel as Jon Su, and I'm recovering from Slack addiction, so you can probably easily find me there if you need. So before I get started on the actual talk, I'd just like to take the opportunity to set the record straight once and for all. This is totally how we Aussies always travel to work in Australia in pre-COVID times. So now that that's out of the way, we can get to today's topic. So today's topic will be basically just some general tips and tricks that you can do as a Silverstripe developer in order to just make that a website or application just a little bit more secure. The topics that I cover in today's talk are pretty much designed so that it can be applied to the majority of Silverstripe projects, regardless of how big they are or how much budget you have. So from your simple brochure style websites to your full-on web applications, most of the topics in this talk you can pretty much apply them if you need. And just as a general disclaimer, any code you see in this presentation, they're designed to be a proof of concept. So if you want to use them in production, you might just need some tinkering or changes, but they should at least point you in the right direction. Okay, so I guess the first question really is, why are we even talking about security in a Silverstripe app? So most businesses these days have some kind of digital presence, and then you always hear horror stories about massive data breaches where millions of records were exposed. And trust me when I say you don't want to be that developer that caused one of those breaches, because it can lead to a bad rep. So I guess as developers, everyone in the room I guess can agree that having a secure application is really important. Especially when your app, stores some type of, sensitive data of users, especially. And then I guess for like a lot of our projects that we do, especially smaller ones where the budget is smaller, there's always a tendency to focus on the functional requirements of the site and what a client wants, and then non-functional requirements like security usually just get glossed over. So there seems to be like a myth amongst clients that we developers are superheroes, which we are because we do magic stuff, and that that they never take shortcuts, and that the code that they always write is always secure, and they always focus on security as they build out the features of a site. But the truth is, I guess, for a lot of us, it's really towards the end of a project when you go for a pen test or security audit, and you get the results back, that security really comes to the table. And then that's when developers scramble to implement any patches to fix any security holes that the security audit has identified in the app. So why this late is better than never? This is obviously really bad practice. So what we actually want to be making sure that we're doing is that we're writing secure code over the entire development cycle, and just not as a item on a to-do list at the end of a project where you just mark it off. So that pretty much brings us to today's talk. I'll basically just be touching on a number of different security features that pretty much can be added to any vanilla Silverstripe application, regardless of how they're actually implemented or how big they are. So before we do a deep dive, I'd just like everyone to meet Jon. This is not me, PS. Okay, so Jon is basically a junior web developer who's totally new to the wonderful world of Silverstripe, and he doesn't know much about the framework. And Jon here has been recently hired to work on the famous One Ring website, which is kind of a legend amongst the Silverstripe community because it's the Silverstripe tutorial site that everyone starts off with. So Jon will basically be showing us some common security things that you need to be aware of when you work on a Silverstripe website as he works on it. We'll see. So the first topic we're going to cover today is HTTP headers. So basically, when a browser requests a page from the server's response usually contains a number of different headers. And then these headers then basically allow additional information to be sent between the browser and the server. And then there's pretty much just some common security headers that you can pretty much add to your application, which would tell your browser how to behave when it's using the site's content. And a good thing about them, they're pretty simple to implement. It doesn't take much work, and they're really effective ways of securing the app. So now back to Jon. So Jon doesn't know much about the One Ring website because he's new to it. So what he decides to do is he visits the Sydney Morning Herald newspaper, which is an online site, because he wants to find more information about what One Ring actually is. He's, however, met with this message when he tries to click on the link to visit the site. So what's this message actually telling him? So this message is basically telling him that the site's SSL, could not be validated, and it's warning him that it could be dangerous for him to visit the site. You'll notice at the bottom of the message, there's highlighted in red. There's actually a little link which says, proceed to the site, unsafe. So if Jon clicks on that link, he can still visit the site, but it will be over a non-SSL connection, which can lead to all kinds of vulnerabilities like man-in-the-middle attacks, where an attacker can basically intercept a transmission between Jon and the server, and then Jon wouldn't even be aware. And because it's because it's over a non-secure transmission, that intercepted data is unencrypted, which makes it even easier. Okay, so if we don't want users to be able to visit the site on a non-SSL, what can we do? So we can basically add something that's called a HTTP strict transport security header, so HSTS for short. And with this header, it will basically tell browsers to only allow a user to interact with the site if it's over a secure HTTPS connection, and to never allow a user to visit the site if it's insecure. So with the header implemented, that warning message that we saw earlier would basically remove that link at the bottom, and it won't allow Jon to visit, the Sydney Morning Herald website at all. Another useful header that we usually can implement is the content security policy header. So a content security policy basically allows a website to define what content the browser is allowed to load on that page, depending on where that content came from. This can be really useful and helpful for preventing things like cross-site scripting, because it basically stops external client-side scripts from being executed on your site if they didn't originate from your domain, for example. So here we got two examples of different content security policies. So the first one at the top here is basically saying, only allow content to be loaded if it's coming from the site's own origin, so the current domain. While the one underneath it is basically also allowing content from a trusted domain to be loaded. And just a thing to note about that second one is it also includes subdomains of that trusted domain. Yeah, so there's a whole bunch of rules about the syntax you can use and add. So you can just go online and search for it if you want to include only certain types of assets like JavaScript or only CSS, for example. Yeah, so just to give an example, so if we had this particular content security policy implemented on that One Ring website, when we try and load some JavaScript from One Ring, it will basically allow it because it's, you've whitelisted it. If you try to load it from this trusted domain, some CSS, it would also allow it because you've whitelisted it. But then if you, try and load something else from like another domain that you haven't put into your content security policy, it'll basically block it and then not let it load on the page. Okay, so how can we add these headers to like a Silverstripe website? So there's usually two ways. You can either add them in a controller before you return the response. You can also add it as part of like a custom middleware, which is the way I prefer. Today I'll just pretty much focus on the middleware approach in this talk. Okay, so for those who haven't used a middleware before, the concept is pretty simple. You can basically think of it as a bridge between, the request being made from the browser side, and then there's the middleware, and then there's the, response returned back from the server, and then it kind of sits in between. And then inside a middleware, we can basically do all kinds of things. We can modify the response. We can do authentication if you want. Just all kinds of crazy things, basically. So to get a custom middleware set up, the boilerplate is actually quite simple and usually looks something like this. So basically, we give the middleware a class name, as you normally would do. The important thing is you'd have to have a process function, which inherits from the parent. And then just always remember to call this delegate function, which is basically telling your Silverstripe application to continue normal execution of the request, so it doesn't just stop at this middleware. And then you can just do your fancy middleware specific stuff here before you return the response back to the browser users. And then there's different ways you can apply a middleware. In this case, if we want that middleware to apply to every single request, we can basically add it to a config file as a setting using injector. And then this will basically say, make this middleware run every single time a request is sent to the app. Okay, so how can we implement headers? What we do is, as I mentioned, you add your normal middleware boilerplate. And it's basically just this one line here that we're calling a new function that we've added called add security headers. And then basically in that function, that's where we can just add our separate headers. So here we have our content security policy so that you only whitelist content coming from the current domain. And then here we have our HSTS header. And then similarly for other types of headers, you can use this type of middleware approach and then just keep adding them before you return the response. So it's quite simple to implement. Okay, so moving on to the next topic, we're going to be talking about passwords, or more accurately, passphrases, which is pretty much the first thing that everyone thinks of when you mention security. So passwords are pretty much would be your first line of defense against attackers, and it's probably one of your most important lines of defense against unauthorized access. Okay, so back to our developer Jon. So Jon is now trying to create a new admin user for himself, but Jon has a really bad memory, so he's not very good at remembering his passwords. So he just wants to basically use the password ABCD as his password, and that's obviously just not good enough requirements for a password. So security standards actually recommend certain requirements when it comes to like how strong a password needs to be. So there's two options. There's the first one where you include at least 16 characters, which is a lot of characters. And then the second one, more popular version, I guess, is a minimum of 10 characters, where you use at least 3 of the following character sets. So for people like Jon who can't actually remember their passwords, it's recommended to just get a password manager, where you only have to remember a master password, and then that would basically take care of the actual memory, so you don't have to worry about what your password was, and you can make them as complicated as you need. Yeah, so basically in order to customize the password requirements in the Silverstripe app, we can add something like this to a config.php file. So basically what we have here is we've created a password validator class instance. We've got a set minimum length so that the password has to have at least 10 characters. We can also call this set historical count to 6, which means you can't use the 6 previous passwords you've used in the past. And then you also add character strength so that it has to have at least 3 of these character sets. And then you pretty much just set the password validator on the member, and then it'll work, basically. So next time John tries to enter, ABCD for his password, he'll be met with a validation error message saying it's too long and, too short, and that needs to be longer. So that's how we can implement, certain password requirements. MFA, so multi-factor authentication, is also probably one of the other most effective ways of protecting your app, just because it simply makes it infinitely harder for attackers to get, both your password as well as your second factor of authentication. It's also highly recommended to install it if it's possible, for at least CMS admin users as a bare minimum. And it's been quite easy to install since the login forms module is now added by default to new Silverstripe installations. So from 4.6 onwards, I think it is. So you basically just have to install the Silverstripe MFA module, which is supported by Silverstripe, and then you just need to plug in an authenticator on top of it. So there's multiple ones you can choose. The one we typically go with is a time-based one-time password authenticator. And then once you've installed these packages, it's almost plug and play pretty much to get it working. So how to install? So as I mentioned, we install the MFA module here. The next step is we install like an authenticator module or another one. And then assuming that this is the one that you used, basically all you have to do is define an environment variable called SSMFA secret key with a random, secret key, so just a random string. And then it's pretty much ready to go. That's almost all the work you have to do. So just one thing to note though, if you're using the login forms module with dark mode disabled, is that you might notice some styling issues. So there's an open issue open on GitHub where they've mentioned this specific issue. But until that's patched, what you can do is basically just use some custom CSS to fix the styling so it's actually displayed properly. But yeah, that's pretty much all you would have to do to get MFA set up, and then it'll be ready to go for your users. Okay, in case MFA is not available for some reason, we also would recommend that you restrict access to your CMS admin URLs. So for example, /dev, which is protected by default anyway in live, or /admin. Even though Silverstripe has anti-automation protection, so you can't just brute force the login. Hackers can still either guess or use your previous passwords from data breaches to log in. So this is always just a good nice to have on top, just in case. So there's multiple ways you can restrict a particular URL. So you can do it by HT access file, or you can or for people who don't want to mess with HT access because no one actually understands how they work. You can just use a Silverstripe application code, which I'll show how you can do. So once again we're going to use a normal middleware, so a custom middleware again. So we have our boilerplate, as I mentioned. So you have your process here. You return the response. Yeah. So basically, before we return the response back to the user, we basically just check for a number of different restricted controllers. So in this particular case, if you're visiting /dev, you'll have a development admin controller. If you're visiting CMS, you'll have an admin root controller. And basically what we're doing is we give it like a set of IP addresses that are valid. So in this case, it'll just be a single IP. And then basically we call this validate IP address function, which I've added here. And that will compare, the user's IP address and then the whitelisted IPs. And then if there's a match, you let them through. Otherwise, you just return like a 403 and then don't let them access it. Just a few things to note about this, though, is you can obviously clean the code up a bit. So you can, hide your restricted controllers and, your whitelisted IPs in like config or in an environment variable. And then you can also extend this functionality to do more than just a basic IP address. You can do, all different types. You can do like, range IP, wildcard IPs, all kinds of IP addresses, depending on which ones you need. Okay, so the next thing we're going to talk about is user session management. So back to our favorite developer, Jon. So while Jon is working on the OneRing site, he gets hungry because, developers get hungry pretty easy when they use their brain too much. And he decides to go out for lunch. He goes out for lunch and then comes back 30 minutes later. He notices, however, that he is still logged in onto the website, which you can, I'm not sure if you can see, but there's like a logout button here, which means he's logged in. So being the developer that he is, Jon decides to go and investigate. And he opens the browser's network tab, and he basically finds that session cookie and its expiry, and he notices its session. So what does that mean? So that basically means that this cookie will be destroyed when a user closes the browser, and because Jon left his browser open when he went out for lunch, the cookie hasn't expired, and so Jon is left logged in. So by default in Silverstripe, if you don't tick that remember me checkbox when you're signing in and you close your browser, you get logged out automatically, which is all cool. And then if you leave the browser open though, you'll sometimes find yourself logged in even after 30 minutes. At least I've tested this up to version 4.3. It happens. And then security standards recommends 15 minutes of inactivity before you require a user to re-authenticate. So just while we're on the topic of the session cookie, so this session cookie is what Silverstripe basically uses to identify a user's session in the app. It's usually stored in memory, and it's sent with every request to the application. And then if an attacker managed to get this session cookie, they could potentially impersonate the user. So to avoid that, what we can do is there's actually a flag called secure on the session cookie. And then if we have secure equals true, it will basically mean that cookie can only be sent in requests over HTTPS. And then if it's a non-secure transmission, it won't send this cookie with it. So I guess the question now is, how can we add a session timeout? And how do you set that secure flag on the cookie? So this first one-liner here, we can basically set the cookie secure setting to true on the session class. And then this will basically automatically add the secure flag to your session cookie. This second line here is optional. So by default, as we saw, Silverstripe's session cookie is in this format here, so PHP sesh ID. But if we add that secure flag onto it, it would automatically replace it with secure sesh ID, which is a non-standard name. And the problem with this name here is that many login tools will actually accidentally capture the value of that cookie because it's non-standard. And in comparison, the standard PHP sesh ID cookie is usually automatically excluded from these login tools because it's commonly used. So we usually want to replace it so that falls back to that default standard name. The only caveat though is that you have to make sure you haven't referenced this particular cookie, and then if you have, then you need to find all those references, and then replace it before you change the setting. And then the last line here is basically just setting the session timeout to 15 minutes, so that if Jon is left logged in after 15 minutes and he hasn't done anything, he'll get kicked out and he has to re-sign in. Just one thing to note about this last line here. This is the session timeout on the browser side of things. Servers themselves also have a separate setting for how long the server remembers a session. And then if you want to adjust how long that time is, you can change this session.gc lifetime configuration setting inside your PHP init file. Yeah, so that's it. It's pretty much for session timeouts. Okay, the next big thing is file security. So that's one of the big topics when it comes to securing a web application. There's usually two types of files you can have. So there's the ones that CMS admin uploads from the CMS, as well as the files that you let users upload from the front end client side. Okay, so back to our developer Jon again. So Jon is now trying to add a new form on the OneRings website, which basically allows a user to upload a property as well as attach a pretty image of the property, which is all cool and all good. So just some general tips for Jon is that he should specify which file types are actually allowed to be saved. So we can either do that by adding the allowed extensions setting on file, or calling the set allowed extensions method on an upload field or file field. Just as a key is always remember to set the correct folder and file permissions in the CMS manually, or automatically if you're allowing someone to upload the file via code, just to make sure you set the proper file and folder permissions so that unauthorized people can't access it. And then if you're streaming a file, so for example, like an S3 file, which is separate from your assets, you can always add logic in place in the controller to make sure the current user can actually view and download the file. So you can just add whatever logic you need, or you can do some permission checks on the user before you allow them to actually interact with it. And then also with SVGs. So SVGs are kind of like the newest craze in the web dev world. Everyone wants to use them because they're cool. So it's usually fine when you include them as assets because developers and designers they know what they're putting in when they add an SVG. Although you still need to be careful because they can cause security problems. The main security problems with SVGs is that they are XML based. Which basically means a user can potentially upload an SVG which has some executable code in it, so like some JavaScript code, some CSS, which can then lead to cross-site scripting, HTML injection. The list goes on. So there's quite a bit of vulnerabilities if you allow them to upload SVGs. So for example, here I've added some basic JavaScript which doesn't do much. It shows an alert message, but if I let a CMS admin upload that file and then use it on the front end, this is what I'll get. Mahaha, I have added this alert message, and so you're a hacker now. So as you can see, if we have JavaScript in an SVG, it'll get executed on the client side, even though we didn't add it ourselves. So there's a couple of options you can do to prevent this. So the first option is you can host SVGs on a completely separate domain. Because if you have the SVG living in a separate domain to your website, it means that malicious script from the SVG can't touch your site's cookies or interact with it. But this is kind of overkill because you need to set up a separate domain just so a CMS user can upload their SVGs. The next option is tell CMS admins or users to convert their SVGs to other formats like PNG or JPEG before you upload it, because this would mean any JavaScript or CSS won't get converted, so it's be safe to use. And then the third option is basically the most 100% foolproof way is just don't let CMS users upload this SVGs in the first place. So that's the option we typically go with. We don't let them upload SVGs. Okay, so I can pretty much bet as much as anyone wants. If a website allows a user to upload files from a front-end form, and you go and do a pen test or security audit, antivirus will pretty much always be a recommendation. That's just simply because the risk increases significantly when you're allowing a user to upload whatever they want from the client side, because you don't know what they're actually uploading. So there's a cool module from Symbio which allows you to install a Claim AV daemon, and then that will run antivirus on any file uploads in the CMS. But it does have a dependency and it assumes that you have control over your own server because you have to install some stuff on the server. So what happens when you on a third-party hosted server and you don't have actual control over that server? Is it still possible to run antivirus? Well, of course it is, because we developers like our over-engineered solutions. So there's basically two prerequisites to our DIY solution. We have a S3 bucket set up on AWS with the appropriate ACLs set up as well, and then a client who's willing to spend some money each month to run that antivirus. So the actual implementation is actually pretty straightforward. So the key concept is that we have our browser, and then we upload a file to the CMS, and then on that CMS we also upload that via the application to a S3 bucket. And then once it's on the S3 bucket, what basically will happen is we'll send a notification to an EC2 server, which has a claim AV daemon on it, and then it'll get notified. And then that antivirus will then scan your uploaded file to see if there's any viruses. And then if there is, it'll delete it and then send you like a notification email. So what we typically do is use this third-party product called AWS S3 Virus Scan, which is both free and commercial at the same time. So there's a free and paid version. And what that pretty much does is it gives you a template which you can use to provision a EC2 server. It will install claim AV daemon on it. It'll set up all the notification stuff you need. And then it'll basically scan any uploaded S3 files. From experience, the cost is quite low. So it's usually about $40 a month for us. So that's roughly 25 euros, I guess, on a small instance. So how do we do that? So basically the first step is we want to install like a fly system adapter for AWS S3. So this adapter library basically makes it easy for our S3 application to plug into the AWS SDK and connect to our AWS S3 without, and then it works alongside our normal file system, which you might have locally. The next step is we'd create an S3 file data object. It doesn't have much. It basically has a title field, which is the name of the file, as well as a path field, which is basically where you'll go store it on the S3 bucket. And then each instance of this data object is basically representing a file on the S3 bucket. Okay, so once we've got that set up, we just basically need to find a way to upload the file to the S3 bucket. So what we basically do is we create a new service that we're going to use to connect to the S3 bucket. And because we've installed that package I showed on that previous slide, we can just create a new S3 client instance, pass it like a AWS key or secret, and then we just also create a new adapter and then specify which file system it's using. And then this will basically allow you to interact with that S3 bucket similar to how you normally interact with your normal local file system. And then you basically will just have some file manipulation functions that you can add. Here I've got a write function, which basically will just upload the file to S3, but you can always add other file manipulation methods like delete, list the directory. It's quite straightforward because Silverstripe uses an abstract file system. It doesn't really care which one you're using as long as you have this adapter. And once we've got this, we basically then just add a form with a upload field on it. And then in the form action, we call this adapter, and then we pass it the file, and then we'll just write it and upload it to S3. And then after that's done, you basically just create a copy of that S3 file data object I showed earlier, so you can retrieve that file or download it in the future. And then you pretty much just need to set up the antivirus on the AWS. If you go to that GitHub of that AWS virus scan product I showed, it will have a list of instructions. Just if you can read, you can set it up pretty much, because it's just follow the instructions, click on the AWS console, and then it'll set it up for you. And that's pretty much it for the antivirus. Next time you upload a file to S3, the antivirus will kick in. It'll scan the file and then if there's a virus detected, it'll delete it, and then you'll receive a notification email. Yeah. Okay, so the next thing we're going to talk about is user input. So I wish we lived in a world where we can trust everyone, but unfortunately, the truth is you can't trust any data that's given by user until you validate it. And then the performance hit to like a web app is usually pretty small, where even though you add in some extra validation checks. So first tip, always validate what the user gives you. So back to our developer Jon. Jon is now implementing his own custom search on OneRing. Because he's new to Silverstripe, he doesn't know there's a built-in site search you can just enable, so he's doing it his own custom way. He then writes the following code. So you typically see this type of code with developers who are new to Silverstripe, or they're not used to using the ORM. If you ever spot any similar code, it should be pretty much screaming out at you about what's wrong with it. So yes, allows for SQL injection, which is basically the execution of bad code in SQL statements. And then even though it's 2020, SQL injection is not dead, because it's like COVID, it just won't go away. So the most easiest way to avoid SQL injection is always use the ORM if you can. So because if you use the ORM, it'll basically escape any parameters for you, so it's SQL safe. So you don't have to worry about casting or escaping them yourself. And I mean, really, try and use it if you can. It'll save you a lot of trouble, and it's less work. And also, it's laser loaded, so it's more efficient as well. If you do find yourself needing to use like a where clause on a SQL query, it's recommended you make a parameterized query if possible. So this is basically where you give it, there's placeholders in that SQL statement, and you only give it the parameters that gets inserted into it at run execution time. And then you can do this basically using this shorthand array syntax here, and then just pass it in the different parameters for your SQL statement. PS, you would obviously just use ORM in the real world for this particular example. And then if you're receiving any kind of input from a user and you're using it without parameterized parameters, always remember to escape it before you use it so it's safe for use in an SQL statement, as I've done here. So just be very careful if you're using SQL select or DB query, and then make sure whatever you pass to them is escaped properly. If you do need to use those types of SQL methods, the convert class is probably your best friend. It has a whole bunch of useful static methods you can use, but the most common one we typically use would be raw to SQL, which will escape input, so it's safe for SQL use. And then just one thing to also note, if you find yourself using SQL selects or DB query a lot, it's usually a reminder to yourself that rethink what you're doing and see if there's a better way to structure your code or redo it by ORM. Okay, so now we're down to the last section. The last section is basically just some general tips on how you can make a hacker's job harder, because we don't want to make it easier. So hackers really thrive when they're given information. So what we want to do as developers is give them as little information as possible to go on. So the first thing is user enumeration is basically when an attacker brute forces your app to either try to guess or confirm valid users in a system. So for example, a good example of what we should be doing is the Silverstripe reset password message. It just says thank you, a reset link has been sent provided an account exists for the email address. So it doesn't actually tell you if the emails are valid or not. So it doesn't actually tell any attackers if they put in like a valid email address. So they don't know. The other thing that we also should be doing is just with our server responses, it's always a good idea to return a generic server error, including requests by Ajax. So basically, don't tell hackers what they're doing wrong, because if you do, they won't try that again. They'll try something else. And then if you want to disallow indexing for certain URLs, so for example, your CMS admin URLs, it's recommended you use like an xrobots tag header over robots.txt header, because robots.txt, everyone uses them, and then you can leak your sensitive URLs to attackers accidentally. And then if you're sending a AJAX form submission, or there's some custom controller action that you have, which is performing some kind of modification to your database, it's always recommended you send like a cross-site request forgery token, which is basically your security ID. Form objects would basically add one by default for you, and then basically in your controller or in your form action, you can basically just call the check request method to make sure it's correct. Otherwise, don't let them submit. Okay, so lastly, back to Jon again. So Jon is now making a basic subscription form for a newsletter, and he decides it'll be cool, to send a confirmation email to the person who signs up, so they know, they've signed up. Surely there's nothing wrong with it. I mean, what can go wrong? It's a simple contact form. Well, actually, because it's a simple contact form, anyone can actually easily submit it. So Jon is now basically, essentially creating an open mail relay, which is basically where a user can put in any email address, and then our Silverstripe application will, send an email to that address. So an attacker can potentially, spam that form, and then like thousands of emails could be sent. And then so to prevent this, what we usually want to do is add a reCAPTCHA to all forms that are easily fillable by bots. So for example, if you have a multi-step form, they're usually a bit harder, so it's not as important. But for simple forms, it's always recommended you have a reCAPTCHA. And don't send a copy to the person who submitted the form. Just a thank you message on that page will suffice for 95% of use cases, I think. Yeah, so hopefully some of you, and mainly Jon, learned some things about security in Silverstripe today. That's the end of my talk. My social handles are there again in case anyone wants to connect. Thank you. Yeah.
Well done, Jon. Thanks for that. Thanks for covering the whole security part.
Yeah. Thanks.
Well, I always feel the problem from a sales perspective with security is that it's invisible, but that it hurts when it's not there.
And clients don't want to pay for it.
Yeah, that's kind of the problem. Oh gosh. So questions, we already have one. reCAPTCHA or better go for honeypot?
Yeah. 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 Yep. I prefer reCAPTCHA because I just find honeypot, it's easily, bots are now getting smarter, and then they can basically tell when you're putting like a hidden field and they just won't fill it in. So yeah, so my preference is always reCAPTCHA. I mean, it's easy to implement. Like the big boss Google work out how to block bots, so you don't have to worry about it. Yep.
Okay, Michael is asking, do you use a security boilerplate for projects?
So we have like an internal module that basically just adds what I mentioned in this talk. So we just bundled it together, so that let's plug and play most of it. Yeah.
Is that one on GitHub?
It will be. Yeah.
It will be. Very cool.
It will be. Yeah, it will be.
Please let us know, because everybody, I'm sure, is super curious about this module.
Yeah.
But I'd say your talk provided a good checklist that all of us can go through to enhance security a little bit.
Yeah, it's designed to be, applicable to most apps. Yeah, regardless. Yep.
Yeah, very cool. So, Jon, thanks a lot. There's one more question from the chat. Andy Smith is asking, what do you do about your VPNs?
So I guess they're asking about the user's VPN. Yeah, so that's why we usually have the MFA plus the IP address. So the MFA is like your main, the main way that we protect the login, for example, and then the IP address is kind of just like a fallback, and it's like a nice to have